All right, guys. So if you can go ahead and open up in your classwork the trimester or comp diagrams PDF that I gave you guys yesterday. When you open that up, right away you're going to see an air mass diagram. So I told you guys that using the diagrams, great method for seeing if you guys really understand the information and spider webbing to a lot of other things. So we're going to go through a bunch of these. Not that every one of these diagrams is going to end up mixed into your final, but the information that you see here is definitely going to be on there in some way. All right, so I'm going to drop as many hints as I can here. At the same time, you guys just need to spend a few minutes and go through these. So right off the bat, you got the air mass diagram. So you're seeing the MP, the CP, CT, MT, CA. Wait, what did all that stand for? Oh, that's right. Continental is the little C, meaning that it's going to be a dry air mass. And then little m is going to be maritime, meaning that it's going to be a moist air mass that formed over the ocean. Remember that always air masses are defined based on where they form. Right? That's what we call the source region. So you got the maritime tropical, and you can see down in the equatorial region, right, in the tropical region. So remember, equatorial is the equator, and then we're coming up from there. So those are the tropics. If you guys are going on a tropical vacation, you'll be down in that region. And it's over the ocean, so you got the maritime tropical. The continental tropical, an air mass that's forming over the land and in the tropical region, that's going to be a hot and dry air mass. So if that pushes into the U.S. the way that this picture is depicting, we're probably going to have a dry spell hitting the Midwest. All right. Above that is the continental polar, which is going to be a cold and dry air mass when those push down from the Canadian region. Again, you're going to have some cold, dry days. Maritime polar is going to be a colder but moist air mass. Think about a nor'easter coming in. All right, and I'm again trying to tie in some other components here. So be open to that. All right, and then ultimately the continental Arctic, that's going to be an extremely cold, dry air mass. And let's remember continental Arctic later on when we talk about types of deserts. Now, an air mass is going to have a boundary, and where that boundary hits another air mass, right, the boundary is where it interjects with another air mass. That's going to create our four types of fronts. So again, great diagrams, but also just a good source of a multiple choice question, right? So the cold air mass pushing the warm air mass up and out, making that cumulonimbus cloud. We'd obviously expect a lot of lightning to be coming down through here, a lot of heavy precipitation, and when we have a cold front come pushing in, that's usually when we get that crazy stormy weather. Looking over at the warm front, that's when the warm air mass is slowly replacing the cold air mass. Slowly replacing the cold air mass. Right? Cold front, very quick. Warm front, more chill. Right? And when we're hanging out in the summertime, we tend to move a little bit slower. Right? When it's the winter time, you're getting out of your car, you're like, quick, let's get in the house, quick, it's cold. I don't know if that helps any all at this point. But down at the bottom, you see the occluded, and occluded is when two cold air masses merge and carry above it a warm air mass, and that's going to give you some periods of heavy precipitation and lingering rain. And then stationary front is when a cold air mass can't push a warm mass out of the way, and instead there's a stalemate. So that's going to give us several days of usually some overcast, things like that. Now, yesterday I said that minerals, rocks, fair game. The only diagram I can think of off the top of my head that really would be helpful in minerals would probably be the Mohs scale of hardness. Right? Most scale is showing you how we're able to test different minerals. But, you know, who knows? Maybe just a picture of streak or a picture of cleavage would be useful as well. All right. Remember, streak is the color of a mineral in powdered form, and cleavage is when you have those clean parallel breaks. But then we come down to the rock cycle. And not only did we do a lab on the rock cycle, but we spent some time talking about it because it really hits home all those ideas that we were talking about in the geosphere. Right? So whether it's weathering and erosion, compaction, burial, melting, all these different rocks are going to be tied into one of those processes. So find the magma, work your way from there. Magma is going to cool to make the igneous rock. Igneous rock can weather to become sediment or can melt to become magma, or you can just metamorphose your igneous rock right into a metamorphic rock, which is what you're seeing in this lower region down here, right? All the things I just mentioned, right? If we're metamorphosing, it means that we're applying heat and pressure to then make metamorphic rock. If we're weathering and eroding, right, we're breaking it into smaller pieces, which then you need the compaction and cementation to make your sedimentary rock. Apply more heat and pressure, come around to the metamorphic. Let's remember that metamorphic can actually become more metamorphic, right? Sedimentary is shown right here. Sedimentary can actually be weathered, become more sedimentary, finer sedimentary. And it just hits home that idea that any rock can become any other rock on any given day. Then we mentioned soil yesterday, and soil is going to be that mixture of sediment, organic material or humus, water, and air. So each one of these layers of the soil profile have a different characteristic. So the O horizon being the organic layer, the A horizon being a mix of sediment and organic material. Then you have the zone of alluviation and leaching, which is your E horizon, where now we're washing anything down. If we're going to wash it down, it's going to end up collecting in the B horizon, and that's where you're going to have a lot of oxides and clays. Then you have your partially weathered parent material in the C horizon, and then R horizon is that bedrock or the parent material. So remember O, A, E, get all the vowels, and then B, C, R in alphabetical order there for B, C, R for the consonants. And then we get to the mass wasting. So this was a lot of diagrams all slapped into one, but maybe one of these end up on there. I don't know. I mean, I do know, but I'm not going to tell you. So you got slump right over in here. It's showing you that curved path. And remember, in class, I had you all slump when we were talking about slump, right? So just like your back curves in the chair. Then soil creep, like imperceptibly slow. You need things sticking out in order to be able to figure out that you got some creep going on. Lahar, mud flow, this is all going to be when you have a lot of moisture mixed in with the sediments, or a lot of water mixed in. Debris flow you have up there. Then rock fall, where you're going to have the talus. Usually I like the cliff type versions, but this one's cute. And then you got the rock avalanche and rock slide. They tend to move a little bit. An avalanche is the fastest moving, but the rock slide usually more of a down slope. Rock fall usually is more like at a cliff, 90-degree type falling. All right. Then we mentioned yesterday topography. And topography, looking at maps, looking at contour lines, index contours, you got it all right there. Right? From map scale, figuring out the distance, to figuring out the gradient, right? When lines are closer together or further apart, right? What's the gradient going to be? right? Close lines, steep gradient, very spaced out lines, gentle gradient. There's your profile. So maybe you have to match up a profile. You're certainly not going to draw one. No drawn, all multiple choice type stuff. All right, straighten that one out. 5 types of dunes. Be able to pick them out. Be able to describe them. When we talk about downwind, that was something that came up yesterday in a couple classes. Right, so downwind is where the wind is going to. So upwind would be here, downwind would be down here. And then you're looking at where the points are over here with your Barcane dune, right? With your parabolic, that's where the points of the boomerang are pointing upwind. Over here, your longitudinal, they're going to go parallel with the wind, and your transverse are going to be perpendicular. Star is the only one that goes out in all different directions. So again, good diagrams. But let's not forget about our glaciers. So we talked about depositional features, we talked about erosional features, and right here you're seeing depositional, right? So depositional meaning that you have moraines, drumlins, eskers, cames, right? These are all nice. Some of the diagrams that we've used this year had a little more detail, but this is really there to refresh your memory, to get you to go back to look at your notes and piece in if there's anything else you need to be looking at. So there would be your erosional features: horns, cirques, arêtes. Now, medial moraine and lateral moraine only found with valley glaciers, which is what you're looking at here, and those actually would be depositional features. All right? Don't worry about Pater Nostra lakes and things like that. On to plate tectonics. We said the 3 main types of plate boundaries, and then we can get into a little more detail. So you got your divergent, convergent, and transform. Transform is when they're just slipping past one another. Divergent was they're moving directly away from one another. And convergent can be either when an oceanic is coming at another plate and therefore it's going to subduct, or when you have continental to continental where they're going to suture together, and that's where you're going to get big mountains forming. So be ready for a diagram or some questions. We had mentioned that you could have an earthquake diagram. So here it's showing you that along that fault, along that point where the 2 plates are subducting in the center over here, you're going to have earthquakes. You're also going to have volcanoes forming on the overriding plate. So as this melts, you get the source of magma to make the volcanoes. Deep sea trench going down the center. So these are key points when we talked about not only plate tectonics but volcanoes. But speaking of earthquakes, this is what I meant by an earthquake diagram. So focus, fault, epicenter. Right, the epicenter is going to be the point on Earth's surface directly above the focus. Remember, you need 3 seismic stations to be able to find an epicenter. As far as volcanoes go, different types of lava, right? So your your pohoi, which that's the difference between rough, jagged, or smooth and rope-like. And then you got your pillow lava, which is going to form underground. Don't worry about blocky lava. The other pictures were useful. Then we talked about groundwater. All right, we did a whole lab on the Long Island Aquifer. You guys were able to see what a confined aquifer looked like, an unconfined aquifer, artesian well, an ordinary well, where the water table is, the zone of saturation, I mean, this diagram literally has everything going on. Absolutely everything going on. All right, so over here you're actually seeing the cone of depression. You're seeing an ordinary well. This right here would be your artesian well. This is your aquitard, or your confining layer, and then this becomes your artesian formation, whereas this is an unconfined aquifer up here, right? And this becomes the saturated zone. This is your water table, and over here is the unsaturated zone. All good things for you to be able to identify. Over here is actually your recharge area, and that's why you're getting all that water creating the pressure that ultimately is going to bring the water up in here, and that's what you're seeing. But that's just fresh water. We also talked about, the actual fresh surface water and meanders, rivers, streams. So this is showing you how meanders and oxbow lakes work. This right here is your oxbow lake. This is where you're starting to set up for that cutting off. Eventually this is going to straighten out and you'll get another oxbow lake there. Remember that you get your cut bank on the outside and you get your point bar on the inside. The point bar is where you get the deposition, and the cut bank is where you have the erosion. We also then talked about oceans and the ocean's circulation, so thermohaline circulation, the Gulf Stream current you're seeing right here where it's drawing the warm water up along the east coast of the United States. That's what makes our winters a little more mild. And over here, why the ocean currents coming down along California tend to be cooler. All right, all good reasons to stay on the East Coast. But then we talked about the phases of the moon, and I always tell everyone, first step here is find the sun. Then once you know where the sun is, find the first moon that's in between the sun and the earth, and that has to be the new moon. If I know where my new moon phase is, then I know where all my waxing phases are, increasing in brightness, right? Bright on right, waxing. And then I know where my waning stages are, and bright on left, waning, or bright left, goodbye. Layers of the sun. Right, we just did this. All right, layers of the sun. So we not only talked about the interior, but then also the atmospheric layers, and then the special features like prominence. You see the solar flare right there, the sunspots, the cooler little portions on the photosphere. Under the photosphere being the convection zone, and under that the radiative zone, and then down in the center is the core. Right? In the core is where you're going to get that nuclear fusion. There is prominence shown here in solar flares. I mean, the solar flares are going to lead to solar wind if that energy can escape the sun's gravitational pull. And then when that interacts with Earth's magnetic field, that's where we get our auroras. All right, the solar system, right? You guys, again, you just did this. So, Mercury, Venus, Earth, Mars, your terrestrial planets, the inner planets, the rocky planets, the planets with not a lot of moons or any moons, depending on which one you talk about. Then you go to the other side of the asteroid belt. Remember that the asteroid belt is going to be depicted right in here between Mars and Jupiter, and then you hit the gas giants. Jupiter being the largest of all planets in our solar system and is in fact a gas giant. Then you get over to Saturn, Uranus, and Neptune. Remember, these are all Jovian planets, Jupiter-like planets. They all have many, many moons. The Galilean moons are actually associated with Jupiter. than Saturn in its most prominent rings, although they all have, all of the Jovian planets have rings. Uranus rotating on its side, things like that. All right, we're almost done. All right, life cycle of a star. Very similar to the diagram that was on your last test, but if there were a diagram like this, remember, or even just questions, right? You're going to go nebula to protostar to main sequence star. Then you got to look at the mass. If it's massive, it's going supergiant. If it's medium mass, it's going giant. And then write it out from there. So giant to planetary nebula to white dwarf to black dwarf. Black dwarf not shown here. So I'm just going to put a quick black dwarf out here. And then on the other one, the supergiant, it's going to go to supernova, massive explosion, and then we either make neutron star or black hole. All right. Then the HR diagram you guys, again, just had on the last test. Hopefully it was pretty self-explanatory. But you got your main sequence, 90% of all stars on the main sequence, right? As the main sequence star expands as it's getting older, it'll move up to the supergiant or the giant, depending on its mass. And if it's a giant star at the end of its life, it goes down to a white dwarf. If it's a supergiant star, it explodes. Now you might think that's anticlimactic, but I think it's pretty explosive and resulting in either a black hole or a neutron star, depending on the mass. All right, guys, so that pretty much is the diagram review for today. What you need to do right now is figure out what thing did Mr. Weavers talk about today that you were like, I don't remember that, or I'm not that confident on this particular topic. And then take the next 15 minutes and just focus on learning that particular aspect. All right, go back to your notes, go find a YouTube video, whatever you need to do. Don't go making, 20 Quizlets. Don't go watching sports film right now. Don't be raising your hand to go outside for a walk. Like, just sit down with your iPad for a few minutes and just study something. All right? It's going to pay off. All right? On Monday, I'll answer any questions you guys have. And, yeah, enjoy your weekend. Bye-bye.